So for those of you keen PWI attendee, seminar attendee followers, you'll notice that these slides are from Phil Winship. Phil couldn't make it today. I think he's on leave, but he gave me the task of sort of delivering this for him. So most of the work within the recycling of S&C is from Phil Winship, and also from Natalie Vocal as well, who's also to do with a lot of this work. So I'm going to run through the work we're doing currently on the Whitemore Recycling Centre, trying to increase the uptake on that. A quick run through on the circular economy, and also rail production CO2 emissions, looking at the recovery of S&C. So this is the sort of the main purpose of this slide deck really, is to give you some insight into what we are currently doing, how we can improve that, and also the carbon footprint that's contained within that. Slight bits on plain line track renewal CO2, and I'm touching on sleepers. Haven't got a lot of material on that because I've lent it to a lot of people that have already put those slides up, but I can always expand where needed. So where this all starts, so we talked about the 2050 Network Rail net zero carbon strategy. You saw a slide from John earlier that sort of explained the different types of carbon. So that's the decarbonisation part of the programme. Within the programme, there's also these minimal waste and use of materials. So the timeline there, 2022, 2023, that's where we're defining the policies for circular economy. So we're starting to put those into some of our standards for 23, and a lot of our tenders will start to include circular economy and low carbon alternatives. So, Whitemore Recycling Centre. For those of you who don't know, Whitemore has been around for a long time. They've been recycling for over 15 years. We have data from 2011 that sort of shows how much they have been recycling. So includes rail, S&C, sleepers and ballast. To give you an idea, Network Rail have actually recycled 93,000 tonnes of steel. So that's equal to 13 Eiffel Towers. And 79,000 of that, so a fair majority of that, is actually dealt with at Whitemore. And that's a saving of 20.3 million. So that's just from reusing that steel. Within ballast, there's actually 1.26 million, equivalent to 15 Washington Monument Towers. Just to put it into perspective, if you really know what that is. I could put it into cheeseburgers, or I could put it into Land Rover Discoveries, but I think you know what that is. In terms of what Whitemore have done, that's 156,000 of that, and 6 million total saving. So a lot of these areas we're looking at expanding and increasing and improving on, and really we want to make them more circular. We want to pull that material back into reuse. I know when we do high output ballast cleaning, we do reuse ballast. And in some cases, I can remember return used to be 70, 75%, 80% really hitting the tops there. But if we can look at using ballast in other ways, other than high output ballast cleaning, and all the other materials, then obviously we're saving, and that's the bigger picture that you'll see later. So Network Rail renews around 200 to 300 S&C units a year. Yes, in austerity terms, that may reduce. We're going to go more into that refurbishment mode, but it's still a lot of S&C. We'll still be purchasing a lot of S&C, a lot of crossings for line-side spares or line-side or for replacements. So the opportunity to reuse, refurbish, or recycle switching crossings, utilising the sort of NR Whitemore Recycling Centre, it's never come at a better time, and that's where we need to really improve that take-up. So we ordered 958 units in 2020. Recent figures for 2022 are 1,053. So it gives you an idea how many cast manganese crossings a year we order. So they're brand new cast crossings from the supplier. So here's just this is the only graph, but this is the current recovered S&C from Whitemore. Starting at 2011, we had 160 crossings recovered and a handful of switches. That soon sort of started to balance out between switches and crossings. And as you can see, sort of an average there over the 10 years of around sort of 50, 60 crossings and switching crossings. The sad thing is, it's depleted. It's gone down. 2021, it's gone down to a handful. 2022, there are figures there, but it's very low. So why is it we're not getting that take-up? So we'll go into that later. What is the facility? So the current capabilities of Whitemore, they have the ability to assess the refurbishment of full depth, shallow depth and bullhead switches. They can also do crossings, fabricated, part welded, cast manganese. They stock in recovered check rails and also recovered expansion switches, whether it's just the tongues or the whole panel. And the reuse of components then into a refurbished either a panel for S&C, pressing switches, also doing any milling or weld repair or grinding to basically bring it up to a decent standard. And they've also got the ability to do some timber layouts and turnout panels and so on. But one thing it does come with is a CFC. So all the items supplied by them do actually have a certificate of conformity to say it is fit for purpose, which is the important thing, because lots of people say, what am I getting? I don't know the level of product I'm getting from a quality assurance perspective. So that CFC really does, it gives us that seal of approval. And 2022, one crossing that was recovered and 6 switches. Not too good. Unused items, so we get a mixture of unused line side, some that have been incorrectly ordered, some that are the wrong length, some that possibly an old line side, we've changed the configuration so we can then use, pass that on or cascade that on. So there's a varied sort of take-up of what we actually have. The actual components supplied, 2 crossings, 6 switches, 8 check rails, and 4 adjustment switch panels. So components are going out, but we're not getting enough in, and again, all those figures do need to improve. There are 2 standards that we have that actually give us good guidance and sort of provide that instruction to those people that may go out and specify the switches to be reused. So 063 is the recycling and reuse of switch and crossings, and 3415 is the refurbishment. So these are good to tell us how we actually can scope them, how we can assess them, how we can refurbish them, how we can reuse them. And the refurbishment of switch and crossings, that goes on to a lot more other things, not just about recycled components, but about how we best refurbish S&C. And that, I think, at the moment is currently going through a revision as well. So again, these are all good documents for us to use. Any of you that are project engineers that specify, that scope, that go out onto site and look at future renewal sites for S&C, should really think about how can I reuse that. And again, read these standards, level 2 guidance, level 1 obviously, level 3 guidance, work instruction, and 2 is the manual. They'll help you just to be able to determine whether you can reuse that S&C. Because I think in a lot of cases we probably just assume actually it's only good for scrap, it's past its sell-by date. But in this day and age where we're doing a lot of remodelling, a lot of S&C is actually being ripped up that's only been installed, say, 10, 15 years. Why can't we actually say, we know the footprint of that, I know where I can put that somewhere else and reuse it. So it is the cost saving and it's the carbon saving as well. Why is it decreased? Possession limits constraints. The fear of overrun penalties, I know from my old days of track renewals, the track renewal lengths we used to do have gone down in halves since then. It could be the plant we use, it could be our recovery techniques. It's too difficult to do. It's not considered in the planning process. We don't have, we've gone straight into rip out mode, break that down into 10-metre switch panels, take it out. There could be a poor perception of the cost. A lot of people think, well, actually, that's not worth a lot of money. I purchased that quite a lot. That's only worth 30,000. That's worth 50,000. But there's more to it than just cost. There's the carbon, and there's also the renewable materials that we're actually, depleting as well. The perceived machinery and equipment that we need, to actually remove and handle the S&C, it's not that different from the machinery that you're currently using to rip out track. And the main big thing with a lot of contracts that are in place that we have with either with alliances or even with subcontractors is there is no sustainability target with any of our tier contracts at the moment. So we need to have that incentive really within those contracts to have a more sustainable and lower carbon installation. So we look at, in terms of KPI, having carbon as a KPI within track. We're looking at that for CP7. We've got KPI values for cost and looking at unit rate cost reductions. We want to look at carbon reduction rates as well. How can we reduce carbon? So that's important for us for CP7, for the overall target for all track renewals, not just S&C, but plain line as well. But this plays a part of that. Of course, it's a credit within that you can then account for and say we are saving 50,000 tonnes, 200,000 tonnes per project for S&C refurbishment. So one example Phil put on here was a set of switches that were returned because they were cut too short, not used. So that's £15,000 wasted on the stock of switches. So they were able to be refurbished and reused again. So what could be achieved in S&C if it was recovered as part of everyday sort of renewal delivery? So there's a reduction in carbon footprint. There's also a cost reduction. So what the current thinking is, around 50% of the cost can be saved. So an average cast crossing is around £15,000 to £20,000. So for us to take an old crossing and to refurbish it and then sell it back, we're talking about half that. We're looking at ways at reducing that, but somewhere around half to give you an idea of that cost saving. Big one for us in sustainability terms is reducing the depletion of natural resources. So you'll see the steel circular economy and how steel is created from the mined resources. So for us, if we can repurpose, recirculate, then we're cutting out that depletion of those resources. Better availability, certainly an emergency for spares. Whenever we have a derailment, we're looking around for a set of switches or something that can match. The first port of call is go to Whitemore. They could have something. They have an inventory list there, so hopefully they'll have something to fit. If not, they can try and make it fit, try and make it work, and see if they can sort of reduce those times. The big one is lead times for S&C at the moment. It's on average around for cast crossing 26 weeks, but they can go up to 52 for some complex ones. Stocks and switches around 16 weeks. And some of those up to 24 weeks. So there is quite a large lead time there that we can save in. Availability of the assets to be cascaded. So looking at an asset that can be cascaded. So it's actually got a plan. So we know that at one point it's installed there, but we've already calculated its second life. It's in a siding somewhere and it's point number such and such. So it's already been allocated. So it's sort of looking at that as well. Strategic spares inventory, so you can look at that from inventory side. Whitemore can be used for that. It can be your strategic spares inventory. If we can get those parts to the part of the rail that we need to, then let's build that into the strategy. And there's improved performance, which is all gained from sort of low cost and so on. In terms of the circular economy, so the diagrams to the right there, that is your linear economy. It starts from your basic materials, manufacture, production into the ground. It's then wasted and it ends. Circular obviously continues that either through repurposing. We say the word recycling, but really we'd like to use it within its intended actual design function, so it goes back into how it was used before. If it goes into another use, it can be maybe a lower usage, lower duty usage, but it's intended really to be sort of used within its intended function. So what are the blockers? How do we remove these from sort of improving that take up? From carbon footprint perspective, as a business, we know we need to start embracing the challenge and doing our bit. So company and personal, we all need to sort of improve on that. We're all being given targets. We don't know what those targets look like. We don't know what good looks like. Lots of figures on kilograms of CO2 and tons of CO2 are sort of spread around, but a lot of people say, well, I can't really contextualise that. What does that really mean? So I think part of our role within TA and pushing out to everyone is to try and determine what those target levels should be so that we know what target and what level to aim at. Because we can't get a net zero track renewal will be very difficult, but we can get somewhere close to it. And we started to look at sort of the tools that we need to calculate carbon and also to look at the alternatives as well. So recycling S&C can make a big impact on that. So touching on rail production, the CO2 emissions and rail production. So you saw a slide earlier on how much CO2 is within track renewals, which I call sort of CapEx CO2. So rail is around 40% of that, so it's sort of a big player in our track renewals. We've got 3 contracted rail suppliers working towards a hybrid electric arc furnace, EAF, electric arc furnace production method. So that's sort of changing from their current sort of blast furnace technology, which is what most people use at the moment. One current supplier has the ability to go electric arc furnace, but they're not currently within contract, so hopefully that'll come in soon. And green steel, which is electric arc furnace, you'll see some figures how much it improves next, but the next tenders will include an environmental weighting requirement. So a lot of our specifications now have circularity clauses, low carbon clauses, and other sustainability clauses as well that sort of allow us to sort of give actual figures as well. So we've got figures for sleepers now that we want to try and aim for. We've got figures for track renewals that we were trying to aim for, that we can start to use. And in future tenders, we'll be looking to people to try and, to achieve those figures. So this is a model, one of our colleagues within TA, Mark Bradbury, we sat down and started to develop this sort of based on some of you guys may know the RSSB tool, which is used for carbon calculation for track renewals and all other projects, OHLE as well. So this was used, dissected. We actually cleansed some of the information because we realised some of the information within there was actually incorrect. And this just basically it shows you the difference between the rail used from blast oxygen furnace, versus the electric arc furnace. So it's actually EAF, electric arc furnace, has 1/6 of the carbon content of a blast furnace. So for us, that is a big game changer. And that's why those contracts in the future really need to. Unfortunately, it's not just about carbon and cost. There's also some other politics involved with how we supply rail from the UK and from other countries as well. So we have to get around those hurdles. But this message for us, it shows if that's 40% of our track renewal CO2 and we can make it 1/6 of that, we can bring that down considerably. And that's where we should be going. A little trip of the rail production and its circular economy, or how it isn't a circular economy at the moment. So we start off with the iron ore mining, the transportation through to the sort of steel making facility. It then gets transported again to the rail manufacturing yards, where it then becomes the S&C. We then have to assemble it, cut it, drill it, make it into S&C, transport it to site, and then install it. So a little excerpt there from our carbon model. Typical F-switch. We say G44, but we've made that equivalent to concrete bearers, so it gives us the same calculation for a concrete bearer. So that's the whole turnout there, 48,000 kilograms of CO2 for a turnout. That's how much you get. So again, we're adopting the model we use for plain line to be used for S&C, because the RSSB tool doesn't do that yet. A lot of this is a work in progress, and we're still sort of verifying a lot of the data in there. But we can make it circular. We can cut out that top part, and we can bring it back into S&C manufacture, i.e. Whitemore, and then bring it back through the loop that way. Yes, there is a certain circular life where we're going to get to a point where we can't really use it anymore, but at least we've given it that extra use and that extra chance. So that's what we're trying to do there. So this is the carbon tool again, under development, as we said. A concrete turnout here. Here we have the full concrete turnout. Previously it was just the rail. That's the full turnout, 88,349. So really, we're using this to look at the different levels. We can go into the concrete bearers, we can go into the rail, we can go into all other areas to change and play around with the tool to see where we can make savings. And reusing S&C would obviously considerably reduce the carbon footprint. So you're talking about 88,000 kilograms there of CO2 per turnout. And if we do 200 of those a year, that's quite a lot. So we also need to bear in mind that if we're reconstituting, there are other manufacturing processes in place and transportation that we need to put back into it. So we won't be losing those. Those will still be there, but we still need to take those into consideration as well. So we need to develop the model to see how we can then look at, if we are reconstituting, recirculating or repurposing our S&C, how we can use that model then to calculate it. So we divide this down into stock switches, cast crossings, concrete bearers, a full set of EVS switches, that's around 10 tons of CO2. Rail steel and that. So rail steel, we use in this example, a lot of this data comes from either the ICE database, which is the inventory of carbon energy database that we hold, that we can get carbon measurements from and carbon data from. Cast crossings, so for cast crossings, it's a more complex process that we use for cast crossings, so it's not directly relatable to rail steel production, so we're asking for some new data on that. And concrete bearers, so concrete bearers is still one of the, next to steel, but it's still a very large part to play, but at this moment in time, we don't really have any particular ways of recycling our concrete bearers. Now, if we can actually reuse the whole panel, great. If we can, yes, we do break down concrete, and we do pull out the reinforcing, and we do use the other parts, but that's not done by us, and it's not being repurposed, so it's still quite a problem. So just the food for thought, if we actually looked at 50 EVS stocks and switches, and 1 in 15 cast crossings, we could actually save 900 tonnes of CO2 a year. So that's being sort of an average 50, so there is quite a big saving there. And that's quite a large proportion going towards a plain line track renewal as well. Okay, so just going on to some other items that we've been either approving or introducing. So many of you are aware of the composite sleepers that we've introduced in 21. This does actually contain a third of the CO2 compared to a G44 sleeper. So it's around, 45 kilograms of CO2. And most of that, as Brian did say, is in the steel base plates. So the steel base plates is around 25 kilos of that. You know, and add on another 2 for a guardrail, you're talking about a lot of CO2. The actual sleeper itself is around 18 to 20, so there's not a lot there. And it is recycled plastic. It's plastic from domestic waste that's recirculated into a sleeper. We've got full PA for 135 and 155. We're just about to consider sites on high speed, but we've got to think about, what are the risks of high speed and, what other concerns are there. So that's our next step. And so far, I think there's around 2,000 to 3,000 installed so far. The bottom photo actually is a recent NR60, back of some S&C on check rail. So we use it check rail, guardrail, tunnels. So it can be used in sort of multiple uses. Top right is a tunnel that was also beveled, so short-ended and beveled as well. In terms of what Sycut do in their circular economy, they call it Circular Economy Plus. If you were to take the plastic bottles that we're actually recycling there, generally they last around 6 months, 5 to 6 months, and then they're back through the process again. And that circle can really only be done around 6 times for the bottle itself just hasn't got the performance, or it just can't do what it's supposed to do. The good thing about the sleepers is that actually gets locked in, so that plastic waste gets locked in for 50, 60, 70 years in use, and then the repurposing at the top there, go back into sidings, depots, or plugging the holes and using it on the same piece of track, moving it along. You could have a maintenance strategy where you do 1 in 3 replacement, and then after a while you've got your full replacement, and then you start to pull that out and do the next piece of track. So you can have a cascade effect on all your branch lines where this could be used. Did some work comparing standard track renewal with composites, so looking at concrete G44s versus Sycut composite sleepers, and looking at that, there is actual a 77-tonne saving per kilometre. So if we think at the moment, we're probably doing around 350 kilometres of track a year, so that's quite a large saving. If you do that over CP7, it soon adds up. Part of the work myself, Phil, and Jamie Wilkes are doing, Jamie and I are part of the Sleeper Strategy Working Group. So we're looking at low carbon alternatives and new sleeper technology. So we're sort of looking at reduced CO2, circular by design sleepers, similar to the Sycut one, and also high lateral restraint sleepers, and bringing that into the design specification as well. So hence Brian's discussion about LERPs. Yes, we want to do away with LERPs. Can we have that within the sleeper itself, so the sleeper's got the ability to perform the same as a LERP will do? And there are some USPs that can do something similar. There's some sleeper profiles that could do something similar. And it's not just all about the weight of the sleeper, it's about the contact surface and how it bonds with the ballast as well. One of the items we did recently look at, so top left, is the Theotrack sulfur sleeper. Myself and Phil actually visited, along with Jamie, we visited De Bont in Belgium. So Theotrack is part of the De Bont group. We went there with Cemex. So this is a sulfur. They basically replace the cement and water part of concrete mix with sulfur. And this creates a sleeper that's got 40% reduced CO2. So it's actually the same CO2 as that side-cut sleeper that you saw earlier. And then you think, okay, that side-cut sleeper is recycled plastic. That's really good. This isn't recycled materials. However, it is circular. So what you can actually do, and we saw this demonstration, it's quite amazing. They heat the sleeper up to 120 degrees. They remove the sleeper out of the oven. So it's a bit like something out of Bake Off. You bring it out, flip it over. They then mix up the concrete inside and then pour it into another baking tray, put the reinforcing in the housings back in, heat it up and then cool it down. So it's quite an amazing process to see, but what it's actually doing is fully recirculating the whole sleeper. And all that material, 99.9% of that material goes back into it. So if you wanted to reshape, remold, then ideally that's where you can go with that. There's some anchors at the end that hold in the tension, and they have been installed on SNCF and Infrabel classic sites up to 200 kilometres an hour, and Deutsche Bahn have just started a 5-year trial on those as well. Final picture, the bigger picture, what we need to do. So everyone's seen, I guess, a lot of the documentaries on where we're going with global warming. And so recovering and the reuse of track and S&C will hopefully help to sort of form part of that. So will the low carbon alternatives for sleepers. So it's our corporate responsibility, and we're also really putting it to everyone around. We've all got our part to play. Every part of this matters. I know we talk about 80 tonnes, 100 tonnes, 50 tonnes, all kilograms. Doesn't seem like a lot, but we've got to start somewhere. And just making people aware that that's where we need to start. And we do have answers, and we do have something alternative that we can use. Hopefully that will make the difference. So really it's hopefully let's stop that reluctance and get the message across to people. This is where we need to be. And step up to the challenge and play your part. Excellent. Thank you very much.